So this is example 12 in the book, right? It says, you have deposited $500 in an account that pays 6.75% interest, compounded continuously. How long will it take your money to double? Okay, and actually, I made a mistake there. I should have left that in. P equals 500. That's the starting point. Which formula do we use for that? Well, we had two. For compounding, there was two formulas. Which is the one you use for continuous? P e to the RT, right? A equals, oh, I want that to be blue. Blue. So we're using this formula. A equals P e to the RT, right? And we know that, which one of those are we going to be solving for when it says, how long will it take to double? John? It's going to be, we're solving for T, which means we need to be able to fill in values for A and P and R. Okay, I can see that the P is 500 and the R is 6.75, which we'll put in 0.0675. But what's the A? What's the A? It's 1,000, right? If you start with 500, it says, what is the time to double? Well, it'll double when A is 1,000. So that's, you got to understand, if it says double, that means the A will be exactly 2 times the P. E to the 0.0675 times T. So that's an exponential to solve, right? So follow the steps for solving an exponential. First step is, no, come on, what's the first step always? Isolate the exponential. In this case, that would be divide by 500, right? When I divide both sides by 500, okay, over here, what do I get on the left-hand side? 2, right? So I have 2 equals e to the 0.0675 times t. So here's the point that I was trying to make when I had that erased up there. I don't really need to know how much I have at the beginning, right? Because whatever I have, if this is double, then when I divide, I'm going to get 2. This 2 right here is telling me double. That's the time to double. Double how much? It doesn't matter, right? If I start with 500, then 1,000. If I start with 1,000,000, then it'll give me 2 million. It doesn't matter how much you start with. Because at that step, when you divide by P, A over P is 2. That's what it means to double. But in this case, they did give it to us anyways. Okay, I've isolated the exponential, then what? What do we do at that step? Come on now. Just take the ln of both sides, right? So that will be ln of 2 equals ln of e to the 0.0675 t. Right? But how does that simplify on the right? What is ln of e to that? It's going to be the exponent, right? Remember, this is like taking the composition of a function and its inverse. So now we've got, I'm going to go up here, 0.0675 times t equals ln of 2. So still haven't solved for t. What should I do? Divide by 0.0675. Make sure when you're doing these kind of calculations, right, that you don't like accidentally say ln of 2, don't close off the parentheses, and then you divide by the 0.0675, because now you've put the 0.0675 inside the logarithm. You don't want to do that, right? So this is 10.27 years, right? So your money is going to double in 10.27 years. Good to know. That's if you get that interest rate. If you could sustain that interest rate for a long time. Because are you not likely to be able to say you get interest rates that high for that long?